Gentlemen, welcome back to the shop. Today we got kind of an oddball. Panasonic cordless drill, lithium ion, 18 volt, 3.3 ampere hour. Its claim to fame is its IP rating. It's IP56. So the first digit is dust ingress, so it's not completely sealed to dust, but it does have capacity to run in dusty environments and not shit the bed. And then the water rating, the 6 rating, is a jet, I believe a 12 millimeter jet of water blasted at it, and no problem at all. So we just got it set up to the crappy load bank here, the brushless DC motor, 3-phase out. We're going to see if we can drive the other motor, and no, there's just not enough voltage created, but fun for an experiment. Let's get this thing apart. I owe this to Matt's awesome stuff. I promised this to him last year, but I never got around to doing the teardown. This came to us from those guys over at Tools in Action. They do the feels good in the hand kind of reviews, but they're the least, I say they're the least cringy of all the shill reviewers. I just say shill because call a spade. They get paid or they get free material in order to review these things. Now, I'm still claiming moral high ground on account of they had reviewed this and it had crapped out, so they sent it to me for repairs. As we can see, no speed control, so we know that the MOSFETs in here are right dickered. Okay, casement PA6, glass fiber reinforced 30%, TPE overmolding, plenty of it, abrasion resistant. Not very chemically inert though. If you'd use this in a greasy environment, you would see this after a few months. This would peel right up off there, but for a carpenter, you're probably fine. This is an interesting feature here. 1, the board comes off easy. 2, there's a tactile switch that's covered in dielectric grease. Oh, there's dielectric grease everywhere. That's part and parcel of keeping the water out. But they have a tactile switch to turn the light on, which is interesting because normally if you need the light, you just bump the trigger a little and it comes on. Tough to see through the brown brominated plastic. You can see all the test points here. So this was tested and then epoxied in. The microcontroller, can't see what it is. Just got a bunch of numbers there. No logo at all. So some sort of off-brand microcontroller. Here in the case, got some interesting stuff going on with some aluminum foil tape. Nice big aluminum / zinc alloy die cast heatsink, specially made, wraps right around, mechanical protection and so forth. International rectum fryer MOSFETs, IRF B3306s. These get fed from the default switch, and there'll be a potentiometer in here, slide potentiometer, as well as a switch for forward and reverse. Now, that all gets fed back into the microcontroller. Only problem is something in here is shot, because as soon as you give power to the whole system, it goes. And I'm not sure if it goes in reverse, but we'll have to check that. It might just, the reverse actually, because there's not an H bridge, it's only a half bridge, the reverse has to be in here, so it'll swap the contacts over. So there won't be any speed control in reverse either. Something going on the power side of this circuit. This is neat here. We never see this, a ferrite bead around the motor leads. That's for noise suppression. Brushed DC motor, tiny little bearing on the back side. One thing I do not like, you can see here, this is the transfer case or the transmission, and real mushy to get it in. It's not real positive, so you got to get like it. You push it over and it's spring loaded, and you gotta hope for the best for it going in. You can see it's not going in. Kind of hoping on a whiff and a prayer in order to get that engaged. Once it is engaged, it stays locked. And same thing on the back side here. Now we can't get it to engage. There we go. We got some bridal veil affair going on here. Some ladies' stockings, what for keeping the big rocks out, I guess, but clearly didn't work on this side. These were given a hot supper, mind, but you know, maybe a few hours of use, hard use, but before she crapped out. And it's not mechanically crapped out, it's electrically crapped out. Bigger, yeah, nice big brushes. Brass, focus, you fuck. Why you no come? There we go. Nice big brush holders. Those are nice brushes as well, copper impregnated. You can see by the coloration. The leads, braided copper and then spot welded to the bronze, very nice. Ultrasonically welded to the plastic and then same thing, spot welded to the brass, rather, not bronze. Nice heavy spring load on the brushes, so you know that they're not going to be floating around and making positive contact. Whilst we're in here, we'll do a quick check of this big nasty diode in case it's blown up. That's might be what's messing, you know, simplest thing first, right? So we got a pen here to insulate one brush from t'other, and just have this on diode check. Hit the trigger. So that's the forward drop of that diode. So that looks good. Now we'll reverse the polarity. See what happens. Yeah, nothing. Okay, so we're good. That diode's good. Prizing up the Sikaflex here. This elastic material. Hold down. It's in there good. And we can see here is your problem. Shit stain right in the crack of yonder MOSFET. It blew the side right out of her, which is an interesting fault because we can't see it. Normally you'd blow this right out and you'd see a little pinhole or even a chunk blown out. That's kind of tough to see. There you go. You see that? See that shit stain? So this is the bad one. The procedure was a rousing success. Unfortunately, the patient didn't survive the operation. So we'll go ahead and get on the DigiKey, get the jazz hands routine going on the gargler, and get some of these coming. We fix this before we send it off to good old Matt. Now, just for kibbles and bits, we're going to check this body diode in these MOSFETs, part and parcel of the manufacturing process. There's a built-in diode, a body diode, they call it, and you can't get rid of it. But you can tell if one is blown up because it won't show the forward voltage of the diode. That is, everything will read 0, where you should have a voltage drop of half a volt or 1 volt or whatever. Now we could look up the data sheet, but that would entail going on the confuser and getting on the gargler and so forth. So, because we see no forward voltage drop, there's nothing, this would come up half a volt in one orientation or the other. We know that that is fried chicken. I was trying to get this A part. Interesting arrangement. I see the fasteners here, but that's for the plastic casement of the gear set. I don't see how to get the motor out. Oh, there we go. Oh, clever. That's a quick assembly there. Just on a couple of plastic tabs. Wow. Meh. That's what's holding the whole thing together, and then relying on the case not to flex. Interesting little arrangement, but you'd kind of want something a little more positive, I think, than those teeny tiny little tabs. I haven't seen that before in a prosumer grade tool. Real nice armature. Unfortunately, can't get the Jesus thing out. So they put the bearing on, and then they stake it here, so you can't get at her. Balanced with epoxy. Nice big fat windings. The back here got the epoxy, what for protecting the comm bars, the connection at the comm bar. Little tiny teeny tiny bearing. Not even 68692Z, 692 something. Tiny, incredibly tiny. That's not part, yeah. Different arrangement. I've never seen that. We'll look up that Johnson. I'm gonna look see at the pinion. That's interesting. That's a steel gear, hardened machine hobbed. It's not powder metal, but it's got to be off the shelf, just purchased that way, because look, they've added a powder metal ring around there to make up the difference in the shaft size. Engage your safety squints. Springen. gear sets. Oh my. Oh my. That is a lot of pinions. Jesus. Holy oh fuck, that's a lot of parts in there. Neat screws in the gear case, they get a bite to them. There's all along running axially along. It's almost like a tap. Oh, you can see it there. See that helical cut in the screws themselves. I guess it helps it bite in there and not come out, or helps it tap its own hole. There we go. Oh, gone for fucking ever. Yay. Some pins. Jesus, this thing's complicated. We get a whole bunch of different gear ratios depending on what is the driven, what is the drive, what is the driving, what is the driven. That is, which is power input, which is power output, and which section is held. So if I hold the ring gear and turn the input, we can see there's a gear reduction. So there's a torque increase here. If we do the obverse, we get a torque decrease and a speed increase. If we say hold the input and turn this, we get a different ratio with the output turning. So if we had some more gears on here and a clutch and so forth. So that is how we get so many different speeds out of a planetary gear set. And there's a huge... That's not... Oh yeah. Oh, that's not the carrier. It's the sun. It's the sun gear. It's the carrier for this gear set. So there's a deep reduction there. Okay, here's the gear change mechanism itself. And what we're doing here is we're just moving this ring gear, this outer ring. Now it's either engaged on the carrier of the planets, here are the planets, and the carrier is that pin. It's either engaged on the carrier of that planet, or if we pull it back, it engages on the planets themselves. So if we pull it back, now this carrier is going to spin slower, which means we get more torque out of it, but less speed out of the output, out of the chuck. Then if we go directly on the carrier, it's going to spin faster. We get less torque, but we get more speed. Well, that's the gear change mechanism. And then it just goes through non-selective planetary gear sets, gear reductions. There's a bunch of stages here. So there's one here, one here. So there's 3 gear sets in here. Well, it doesn't want to come off. Nice chuck though, Jacobs. That means it's proprietary. Normally, it's funny it's Panasonic went with Jacobs because there's that company in Japan that does all the other chucks, high quality chucks. Now we see the rust on these pins for the hammer mechanism, which is surprising considering this is, you know, water rated, not immersion of course, but water rated drill. And we see the parts super rusty here. Wouldn't take all that much for those to kind of rust weld themselves in the little hole. Okay, now I'm going to see if I can get these parts. Before I start putting it back together, I got to order the parts. So I don't want to waste my time friggin' and farting with all this gear set if I can't get the parts. I'm just gonna you know, recycle it right into Mother Earth Gaia. If I can't get the parts, I'll fix it though. But as far as the Panasonic drill, yeah, looks okay. Super complicated, you know, very robust whacking mechanism. Not a bad little motor. Johnson, 18 volts. You know, same problems as all of them. They blow the guts out of the MOSFETs. Nice little cooling fan there. The thing is that cooling fan is directional, and this is a reversible drill. It's kind of an oddball feature for that. What else? Oh, we got to have a look at the battery, of course. So before I sign off, we'll have a quick peek at this battery. Okay, there's the batteries. I was hoping to see an LG or something in here, but of course Panasonic does have that deal with Tesla to make batteries for the Tesla mobiles. CGR1, well, 18650 Ka lithium ion, MH12210. So let's have a look, see at that. A different arrangement of the balancing of this thing, proprietary connectors there. Just like the other Japanese tool, the Makita. We see silver plated contacts. Okay, we're in Biznatch. $3 a piece from DigiKey. Of course, didn't get out of there without spending the obligatory $80. So close to free shipping, I just couldn't do it though. You know, because you go in there, oh yeah, I gotta get some more solder flux, I gotta get some more solder, some reflow stuff. I might as well get a ruler, better buy a t-shirt. You know the deal. You just can't, yeah. Okay, these Panasonic batteries, they're not that great. 1750 milliamp hours, 20 amp discharge. Nothing really crazy considering these are the battery manufacturers that, you know, they're taking Tesla to the moon, man. Or boring underground, who knows. We'll just leave this big old mess of bobbins and doodads here on, hopefully on the off chance that something gets up and walks away, and then we won't have the parts to put it back together. But barring that, it'll be a couple days before I get these parts, and then we'll see if we can remember to get it back together. I mean, the quality, not bad. These Johnson Motors, Johnson, that's a Chinese company, founded in the 59, 1 point some odd billion in sales in 2006, so pretty big outfit there now. Makes motors for vehicles and tools and all sorts of stuff like that. As far as the quality, you know, if you need a tool that you're going to use outside and it's going to get wet very frequently, this is going to last you longer on account of the circuit board won't get crapped out on you. But we saw, you know, it had some hot supper and didn't like it, blew the MOSFETs right out of it. So it's kind of one of those things. It does have a hell of a nice chuck though. Hell of a nice chuck. Batteries, lackluster. You know, depending on the price point, you can pick this drill up for $100, $150. Might be worth it. I'm not sure what they're going for. Hard to find parts for though, and all that kind of thing. For as far as a prosumer tool, I don't know if you want to go with the Panasonic. Thanks a lot for watching. Keep your dick in a vice. Some parts came from Didgeridoo, Didgeridoo, DigiKey. Tough to make fun of. What the fuck is this over? Ah! Academic plagiary. I just bought this, what, for stealing the ideas from. It's longer. That's maybe a good idea. Oh, fuck yeah! It's my space lady, Vajayjay, what, for going to Mars mission and so forth. Oh, yeah! Just like a real ladies Vajayjay. Comes with a cold pack you gotta thaw out prior to use.